So we're going to continue talking about Unit 1, Introduction to Physics, and it comes down to, it's more of a introduction to science. And what is science? Last time we talked, gave us a little bit more information, kind of the scientific method and some of those types of things, and that I think that worked out all right. So today we're going to continue talking about the scientific method, and this is where we left off. Maybe some of you got a little rushed, but regardless, so we're going to start all over again. Okay, and that is controlled testing of the properties of a substance or system through carefully recorded measurements. Those measurements can be through observation, meaning you got to pay attention. Okay? You got to see, observe, look. Sometimes measurements are with rulers, graduated cylinders, calipers. Okay? A lot of different types of measurements. So not all measurements are with a utensil or a tool. Some of them are made with just your eyes, your observations. Such as the example that we went through last week when we had the paper falling. We didn't take the time in which it actually fell, we just observed, right? Now, what would be best would be if we measured the height that it was dropped from. If we used the crumpled up paper and actually timed it as it fell. Those would be some things that were controlling the variables. Now, the variables that we control can be a lot of different things. Would we want to have a lot of open air when we're trying to drop something? Well, you wouldn't want your windows open, because then that would blow air in, and that can have an effect on how fast something drops. However, if you're making measurements about something else, having your windows open might not be a big deal. Controlling what we can to minimize the negative effects can be a thing. There are reasons why there are laboratories in the world that are multiple stories below the Earth's surface, for the sole reason to remove certain variables. And it is there that the variables that they're looking for can still be seen without background noise, so to speak. There are measuring tools that scientists launch into orbit, such as like the Hubble telescope, that they put into orbit far enough away that the Earth's atmosphere does not interfere with what they see. The Earth's atmosphere is a variable that they're choosing to control by taking it out of the atmosphere, so that they can get cleaner shots. They can view things differently. That is why we need to control the variables. Applying the scientific method doesn't work for all situations. And that in itself can be difficult for some people. The stock market is not something you can use the scientific method for. Now, they try to, as much as they can, look at trends, patterns to help with the stock market, but it's not something you can apply the scientific method to because there's too many variables. However many people are actively participating in the stock market adds a variable. How you buy and sell stocks is different than how I buy and sell stocks, which is different than how maybe somebody else and somebody else and somebody else buys and sells stocks. Because of that, there's too many variables. They try to look at a plan, they try to guess what's going to happen, but you can't. So trying to control the uncontrollable. You don't worry about it. You can't. Now, what a lot of people want to say is that the scientific theory automatically becomes a law. But a theory explains. It explains certain chemical phenomena or certain physics type things. Einstein, which everyone loves to look at because he's probably the more popular physics person, has theories. He has explanations of why we have what we have and see what we see. Einstein's theory of relativity explains why light bends. He doesn't say light bends. We already know that. His general relativity explains why it bends around massive objects. Okay? It doesn't define anything. Newton has many laws, very concise statements. They do very little explaining. One of the more famous Newton's laws, every action there's an equal and opposite reaction. There's no explaining in that, is there? It's this, this, this. And it's kind of like, oh, okay, so what? Or his first law. An object at rest stays at rest. An object that moves keeps moving unless another force acts on it. It doesn't explain why it's moving. It's moving. It'll keep moving until something stops it. Okay, all right. Then he has his Newton has his law of gravity that explains why their objects orbit other objects, and he had to invent a whole math for that. He had to use basically calculus, a class that many of us probably will not take. Calculus was invented for the sole purpose of explaining Newton's laws, both of motion and of gravity. So I always joke that gives math, the only reason math exists is to explain science. Or I give math a reason to exist. So regardless of what we think, theories do not automatically become laws. They can be verified, but they do not automatically become laws. So, as I mentioned before, Newton's third law states for every action there's an equal and opposite reaction. Doesn't explain anything why it's reacting or what it's doing. And laws can also be mathematical in nature. Force is equal to mass times acceleration. An equation that usually is used for Newton's second law of motion. Newton's second law of motion, the one that barely anybody remembers, an object will move in the direction of a force, or an object will accelerate in the direction of a force. That's what that equation is saying. And if you don't have an acceleration, most of us are mathematically inclined to know that if A is equal to 0 and M can be very big, what does F equal though? 0. Because A times 0 times any number is just that. So whether it is a statement or an equation, the law is that. It is a law. Very rarely does it ever change. And like I've said before, theories are explanations. They have a predictive component to it. In a way, a theory is almost like it's a hypothesis with experimental backing. And so sometimes we do have to change the theory. And that's kind of like, we say that no object can move faster than the speed of light. That's a theory. It's pretty well documented theory. But if someone is able to find a way to go faster than the speed of light, we would have to change Einstein's special relativity. Now we can use some hypotheticals and say that an object traveling at near the speed of light and an object traveling at near the speed of light are approaching each other. And therefore then we have the perception thing that we get to deal with. And that just throws a lot of fun monkey wrenches into everything. And so therefore that's how we think about, if this happens, we can change that kind of, so to speak. But it is that. Theories are more likely to change very small changes, but they can change. So believe it or not, that is all the notes for this part. Now we're going to spend a lot of time doing a lot of activities, working out. If we do some notes, it'll be like, how do I do conversion problems? That's what we end up doing. So that's pretty much the part A. What is science? Scientific method. There we go.